Our first speaker is Matthew Pustelnik from Takeda. And this morning, he's going to talk about ChemQ, which is a search system in Takeda that can do search in not only internal database, but also public database, including ZINC, PubChem, Aldrich catalogs. And this system is built using mostly open source component, with the exception of ChemAxon's JChem Base and Marvin.
Good morning. Hopefully you guys didn't have a rough night like me. But it was good. So let's get started. How does innovation get started? This is a topic dear and near to my heart, and I've wondered a lot about this in part because of my background growing up in Silicon Valley, watching the tremendous advancements in the semiconductor industry and basically high technology. One would say, and actually Ramesh said this yesterday, necessity is the mother of invention. And a lot of great inventions have been discovered by this. The cotton gin is attributed a lot to this statement. Opportunity and circumstance. If anybody has read Outliers, this is definitely one area that the author points to as an important factor where innovation gets started. Straw man proposal, where somebody actually puts a proposal and then other people try to knock down that proposal and try to see the shortcomings of that. Or proof of concept, and this is the mechanism at which we really pushed ChemQ within the context of Takeda. We utilized ChemAxon's example database querying tool, and from that, as a proof of concept, we were able to build out ChemQ and launch that within Takeda. So what's the need, and why do we need a generic chemical query system? Well, if you look at right now, there's so many different chemical databases that exist publicly and internally. And so we had this battle within chemistry that they wanted to search all of this public content, but our legal team was saying, well, once you draw a structure, if it's not a secured website, it's just going across the internet. And so our legal team had a lot of restrictions on our chemists searching public domain content. So the thought exercise was, why don't we bring that content in-house? But with bringing content in-house brings a whole other logistics problem, how to maintain it, keeping it up to date. And this is an issue that we suffered a number of years ago, so we kind of said, okay, well, how do we make a tool that is very simple and can maintain public and internal content? The other part was that chemists were demanding a tool for this is because they wanted a mechanism where they can search content internally and externally to actually drive new ideas for intellectual property seeding. So we identified just kind of the basic system requirements, an ability for the administrator to quickly create, configure, and deploy new data sources. In data sources, we just use this terminology. You can think of it as PubChem, ZINC, et cetera. We needed a mechanism to update the data for the data source without disruption in service. And in large part, since this system was actually going to be deployed in a global context, we really had to figure out a mechanism in which there was zero downtime. So we had to work within a clustered environment, very minimal downtime, and being able to update the content. Now, from the user's perspective, they just needed a way to query the data source, see the chemical structures and various different attributes, view the results, export the results, cherry pick hit results across queries, and that was kind of the first set of requirements that we got from the user. Now, as we started to plan and develop the system, we started to think about, well, if you build a generic query system, it can actually act as a black box but also within the context of other workflow processes. So for example, you might have reagent procurement. So you still need chemical structure searching. That's kind of the foundational component. And so we designed, or we intended to build the system as a black box, work completely independently as a structure searching tool, but then also to be embedded within the context of another application so that they can be integrated and include different workflow processes. So there was this discussion, which chemical intelligence engine should we use within Takeda? Well, this was kind of a no-brainer decision for us because we've been using ChemAxon components for more than 10 years in San Diego. So we had existing licenses across a lot of the Takeda affiliates. Obviously ChemAxon's a mature and leading cheminformatics vendor. We had a great long-standing relationship with ChemAxon, and we also possess a lot of expertise through the course of 10 years. So we took the JChem example database tool, and we actually looked at it, got it up and running, and it really met about 50 to 60% of our needs. So it was a great way as a starting point or a base to actually show to the chemists and our users saying, this tool already exists. Obviously, there were some additional enhancements that we had to make, and I will go and discuss those. We also had a limitation. I'm not sure if you guys have recently been audited by Oracle, but we were. And what we discovered was that we were actually in license violation of Oracle's license. So we had to actually turn off CPUs on our main database server. And we discovered that development seats are no longer free. If you actually develop on Oracle Enterprise, you have to take a license for it. So this is where we said, okay, we don't want to pay Oracle any more money, so let's build this on an open source database. And that's what we intended to do. So we built the proof of concept. We completed it. It was a goal for informatics last year for us. We loaded 5.3 million compounds, less than 8 hours. And we actually found, to much our surprise, that the query response, when I say acceptable, it actually was really good. This actually just took 2 days of effort to show this proof of concept to our end users. And we learned a valuable lesson in this proof of concept, because giving something tangible to end users is saying, this is what the tool might look like. They can say, well, does it do this? And ask questions out of the system. And it really helped us kind of guide the requirements and the system for building out of ChemQ. So here's what the proof of concept looked like. We used JC Manager. We created the tables. There's plenty of documentation off of the ChemAxon's website how to do this. We imported SD files and then provided a query interface. And this is all out of the box. There's not a whole lot you need to do here. Here's the results. And there's the exporting. So if you recall, the basic requirements that the users asked out of the system are there from the proof of concept. So we did a gap analysis. Okay, so we have this proof of concept query tool. Now our end users wanted a little more. And then also we had to think about internal Takeda policies of the system. So obviously it didn't fit the Takeda UI standard. So when we build web applications, we don't use frames. There was no authentication built into the system. And we also had to have a mechanism for access control. We had to support both English and Japanese, and this is one of the areas that we had to overcome, but we partnered with ChemAxon, and they were able to overcome some of those issues. It needed to have configurable query input. So you'll notice the proof of concept, all of the input was just text entry, right? The users wanted guided entry, so drop-down boxes, check boxes, radio buttons. But from the administrator perspective, we needed to be able to configure that for each data source, because some things obviously will remain as text entry, but other things needed to be populated with pull-down options. And that was to the next point. We needed a fields administrator, hiding, labeling, adding tooltips, making certain fields searchable. Some fields we disabled. We needed a mechanism for user auditing, and this was primarily for determining the adoption rate by the users. We needed administration capabilities, being able to cache and activate tables, being able to re-import and reconfigure at runtime, and then a better mechanism for record detail view and printing, and then resort sorting. So this became the requirements for version 1. So here's now ChemQ that we modified from the proof of concept. So you have this main data source description page. You click on the title, and it takes you to the search page link, and then shows the results. You can export the results. You can cherry pick the results, and you can select the records to drill down and see a detailed view. So here's the search interface. We added this quick structure retrieval. If you know the ID, you just punch it in, and then the structure shows up. We worked with our chemists to actually use a template to set up the buttons and the interface for Marvin. Here's the structure drawing area. We enabled searching by key identifier. So each identifier can be put on one line. We have this ability to select the different fields that you want displayed on the results. And then the field inputs and tooltips were also put on. And this allowed, and we were able to actually set up a mechanism to configure. We actually used JSON, JavaScript object notation, to actually configure the system, and it ended up becoming a good methodology for us. So here's the search interface and options. Select search type. Input results display. This is where you can actually say, I want the results displayed in a matrix or list format. And I can say, okay, how many columns do I want? How many records per page? We can search within previous search results. We can sort based upon input conditions. We could save searches. And we also get a history of your past 50 searches. And then you can actually click on any of your past searches or save searches and activate them and modify them. So here's what the results interface looks like. You can hit highlight and align, cherry pick results, navigation buttons. We removed all of the frames. You can clear or view just the cherry pick records. You can name a search and save it for later for subsequent execution. You can export the search results and select the fields that you want to export, and you can search the search results after the search. So this technology stack was primarily web-based on the front end. We used Yahoo UI components, Marvin, JC Manager to create tables and do data importing. And then we used a Java template engine called Web Macro. The middle tier is all Java. The one thing that I'm going to actually talk a little bit later here is if any of you within large organizations need single sign-on authentication across multiple domains with access control at each of the domains, and this happens when organizations take over and merge and they have separate domains, you'll probably want to pay attention to JASPA. It's a really cool technology. And then for database persistence, actually the ChemQ, we've tested on both Oracle and Postgres, and it works fine. And we did a lot of JSON configuration. The other thing that we'd like to do eventually is to actually move to JSON as the data persistence layer. So JChem Base obviously was the chemical intelligence that drives the whole system. So this is JASPA. And what we had was that when we deployed this tool, all of the different research affiliates across the globe for Takeda were going to be using this tool from a single data center. But what we didn't want to do is manage access control for the folks in Boston here, or the folks in UK or in Japan. So we said, you manage your own access control into the system. You manage your own users, you give them their own permissions. So what that required a tool is that when we do authentication, it has to work across the trusted domain network. And then we would actually query out to their separate domain to determine if they had group membership or role. And JASPO did all that. And this is just a schematic representation. And it was really easy to configure, and it was a big time savings for us. So these are the various different data sources that we have within the system. And we did this within a matter of like 4 months. Once we built the tool, it was really easy to configure new data sources and import them in. We have plans to add more. So in summary, it's an open source collaboration. We actually want to launch this tool in an open source environment. We know that we don't have all of the time to commit to it, so we'd like to find out if there's interest. We know ChemNavigator is interested, and some of the content providers. So if you're interested, please come talk to me. So this is a roadmap. I'm running out of time, so I'm not going to actually go into detail of the roadmap. You can come talk to me. And then these are some of the future modules that we'd like to actually work on. So I just actually want to say thank you. And I'm willing to demonstrate to any of you, because we do have a version that's up and running that I can show you guys.
Just a quick question about this commercial database. I didn't understand. Did you actually import the data into your house, or you are using commercial website that use a web service or something?
So we took all of the PubChem compounds. We took their SD file and just imported them in. Now ChemQ actually has a mechanism to monitor a directory. So we can actually put a background process that actually goes out to PubChem, pulls the files automatically, and then ChemQ just actually watches this directory. And whatever files sitting there, it just loads into the database. We actually did a lot of upgrading, adding new data sources, actually upgrading a major version of JChem, and the system was never down. And we're able to do this because we've configured this tool to actually operate in a clustered environment, and they actually work on separate different data repositories. So there is no downtime to the user.
Just a follow-up question that do you think that there might be any license violation because some commercial database wouldn't allow you to download?
You have to be careful, right? So you have to make sure your public content allows you to actually run this in-house.
Thank you for the good presentation, because we have a branch, Japan, US, and UK, so it is very helpful for us. So I have one question. How is the access speed from the Japan and from the UK? You have the one central databases, or you have similar server in UK or Japan?
So we're operating as a single central system, so it's actually running out of San Diego. And all the research affiliates actually access the San Diego data center. But the system was designed to be completely self-contained. The system in San Diego is actually running on one box. It's not multi-tiered. Everything is self-contained on a box. So we treat it like an appliance, right? So if we need to actually run it within Japan, go ahead, because it's all self-contained on one system.